We're continuing with 5.1, systems of linear equations in two variables. Linear equations in two variables. I'm pretty sure you remember this, but I will present everything as if we don't know anything. So let's take a look on page, I'm on that device, I'm on page 555 if you'd like to enter it. 555. So first of all, I'm just going to copy one system. Let's say I'm copying 6 on page 555, and that is x plus y equals 6 and y equals 2x. So the question here is, what am I trying to do? It says solve the system. What am I trying to do? So before we even look at the system of two linear equations in two variables like this one, we have to remember that there are three possibilities. So this is a line and this is a line. Systems of linear equations in two variables. So what is the first possibility? The first possibility is that the two lines intersect. So if this is this line and this is the other, they intersect somewhere. This system is called consistent. Consistent system. It has solutions, but it has only unique, we say. Unique solution. If you don't like the word, just say one solution. Unique solution or one solution. The equations also are called independent. Independent equations. They don't depend on one another. They don't have anything in common. They do have what they have in common is this point. This point where they intersect, that point verifies this equation, it verifies this equation as well. Here's a second possibility. Second possibility is when the two lines are parallel. If the lines are parallel, the system is called inconsistent system. Has no solutions. Inconsistent. No solutions. Parallel lines. And we do have a third possibility. But of course, I don't have enough room there. Sorry about that. So moving here. Here's the third option, not the fourth, the third option. Okay. I have this line. One equation represents this line. And here's the other equation. In other words, this. These are the two equations. Which means consistent system means infinitely many solutions. And the equations are called dependent. They are the same. Identical. Okay. So I'm given this system. I don't know which situation this is. Situation 1 with one solution. Situation 2, none. Situation 3 with infinitely many solutions. Every point is a solution belonging to both. But I know what to expect. Okay. We're going to look at two methods. There are many methods of solving systems. Methods like graphing, matrices, Cramer's rule, etc., etc. Substitution and elimination. We are going to look at two methods, substitution and elimination. Some do not like this, but they call it the adding method. Whatever you prefer, it doesn't matter. It's the same thing. In this particular problem, we are asked to use substitution. I know you remember this. What am I going to do? I see that the second equation is already solved for y. All I have to do is replace this y by 2x in the first equation, and the system is solved. So then I have x plus 2x equals 6. X plus 2x equals 6, combine like terms. This is 3x equals 6, divide by 3. I got x equals 2. This is not enough, but once I got x, I know it's this option for sure. I was able to find the x-coordinate of this point. I will be able to find the y-coordinate of this point by simply replacing x by 2. So 2 times 2 is 4. So then y is 4. The ordered pair is 2, 4. And there is no other solution. Two lines cannot meet in 2 points. They can meet in 1. They can never meet, or they meet in all points. They cannot meet in 2. Okay. At this point, we may skip sometimes, but on a test situation, homework situation, I will always go back and check. What do? Both equations have to be 2 here and 4 here. The point has to verify both equations. If it does not verify both equations, it's not the point of intersection. It's some other point somewhere else. Is it 2 plus 4, 6? Yes, it is. Is 2 times 2, 4? Yes, it is. Only now I can say yes. I checked. This is the method of substitution. Feel free to choose anything you like in the book, page 555 for substitution method from 5 to 18. If we don't need another, if this is clear, then we move on. But if you want to choose another, maybe one in which we have to solve one equation for. Yes, let's do 14. Do you have anything else in mind, or can I choose 14? Is anyone listening? Anyone? Just anyone?
Yeah, 14's fine.
Thank you. I wasn't checking whether you were asleep or not. Okay. In this particular situation, y, the second equation was already solved for y. I didn't have to do anything. But here I do not have any of the two equations given in the form of y equals or x equals. I will never substitute for this x because its coefficient is 2. I will never solve the equation, in other words, for x. I will never solve this equation for y because its coefficient is 5. I will never solve it for this y because its coefficient is 6. This is my only and the best option. I will solve this equation for x because the coefficient, the number in front of x, is positive or negative 1. If it's any other number and I cannot simplify, I will not, because it becomes more difficult than it needs to be. But since the coefficient of x is positive or negative 1, I will move 6y to the other side to solve for x. I still have negative x equals negative 6y plus 8. And yes, I will multiply or divide by negative 1. So x equals 6y minus 8. I solve the second equation for x. I have to go back to the first one and replace this by this, because x is the same with 6y minus 8. So I will replace this x by 6y minus 8. So 2, parentheses, 6y minus 8 plus 5y equals 1. Once I perform the operations here and get y, I'll go back and replace y here to get x. Distribute 12y minus 16 plus 5y equals 1. 12 plus 5, 17. The negative 16 goes to the other side, it becomes positive. Lucky me, plus 1 is 17. Nice. Y equals 1. At this point, I immediately go to replace y by 1, and that is 6 minus 8, which is negative 2. So x equals negative 2. The ordered pair solution of the system, again, is type 1, appears to be negative 2, 1. Do I trust this? No. No, I don't. I go back and check. Negative 2, 1. Negative 2, 1. 2 times negative 2 is negative 4, and plus 5 is 1. Yes, it is. Negative 2 with minus in front will be 2. 6 plus 1 will be 6. 2 plus 6 is 8. Yes. Only now I will say yes. I don't need anyone to tell me whether this is correct or not. I can always go back and check. And this is the method of substitution. Let's look at what we call elimination or the adding method. So here's a question. Any questions for me, please? Anything? Sorry. Any question? Any questions for me?
I don't have any.
Thank you. Okay. Let's look at what I like to, let's call it adding, because the book it says adding, which is correct. I don't have anything against it. We will be adding. We will be adding term by term in a minute. So, for example, let's start with 22 on the same page, 555. 3x plus 2y equals 14. And 3x minus 2y equals 10. The reason why I like to call it elimination, because I will eliminate one of the variables. Will I use substitution? No. The coefficient of x is 3. No, I don't want to use substitution. The coefficient of x is 3. 2, negative 2. No. But I notice that if I add, so you understand that if I decide to add 5 to both sides here, I'm allowed to. I'm adding 5 to the left-hand side and 5 to the right-hand side. I'm not changing the equation. But I don't want to add 5. I want to add this side here and this side here because they're equal. It's like adding 5 to both sides. So this piece will be added here, and this piece will be added here because I'm adding 14 equals 14 on both sides, but in a different form. And that's when I realize that 2y minus 2y will go away. When I add these two, I get 6x, and when I add these two, I get 24. Of course, when I divide, I get x equals 4. Just like that. But it was prepped for us. That's the reason why I chose that problem. It was already prepped for us. What do I mean by that? It had the positive 2y and the negative 2y ready for us. Now, all I have to do is replace x by 4 in either one. It doesn't matter. So if I replace it in the first one, then I have 3 times 4, which is 12, and then plus 2y and equals 14. I know how to solve this. I move 12. It becomes negative. So 2y equals 14 minus 12, which is 2. So then y is 1. It appears that the solution is 4, 1. Do I trust this? No. No. 4, 1. 4, 1. Okay. 12 plus 2, 14. Yes. 12 minus 2, 10. Yes. Only now I'll say yes. But of course, this was a simple situation in which I didn't really need to do anything. But just remember that I can add, these two are equal. I will add 14 on this side and this on this side. And it happens that y went away. It was eliminated by the adding situation. Any questions? Any questions? Okay, let's look at a slightly more difficult situation, like 28. 28 is not that straightforward. Here's why. So 2x plus 3y equals negative 16, and 5x minus 10y equals 30. Well, I want to eliminate one of the variables, but now I have to make a decision which one. The coefficients here are 2 and 5. If I want to eliminate x, then I have to multiply both equations by something. The least common multiple of 2 and 5 is 10, which means I have to multiply this by 5 and this by 2, but one of them has to be negative. So that this one, let's say, becomes 10x, and this one becomes negative 10x, so I can eliminate them. That's one option. If I decide to eliminate y, which I would normally do, because I already have the plus and minus I need. Is it difficult for us to multiply by a negative number? No. But it's safer once I already have plus or minus. And since I have to multiply both equations by a quantity, it doesn't really matter. If I choose to eliminate y, the least common multiple of 3 and 10 is 30. So the top equation will be multiplied by 10, so that I get 3 times 10 is 30. And the second equation will be multiplied by 3, so I get 3 times negative 10, negative 30. See, in this system, for this system, I had to prep the equations. Here it was very easy. There was no need to prep anything. I had to just add, and that was it. Okay, so now multiply by 10, not pick and choose. I have to multiply everything by 10. So 20x plus 30y equals negative 160. The second equation now, 3 times 5x, 15x. Of course, 3 times negative, it better be, so I can eliminate this, equals 3 times 30, 90. Only now I'm ready, after the prep, now I'm ready to eliminate one variable. And yes, according to plan, this goes away. But remember, I had to find the least common multiple of the two coefficients of the variable that I'm trying to eliminate. Now I add exactly what I see. I perform the operations I see. So this is 35x, and this is negative 70. Luckily, I divide, I get x equals negative 2. Exactly like before, I go back anywhere. Let's say I go back to the first equation. 2 times negative 2, negative 4. Negative 4 plus 3y equals negative 16. I add, when I move negative 4 to the other side, it becomes positive. Negative 16 plus 4 is negative 12. Divide, and I get y equals negative 4. We claim we don't know. We can easily make mistakes here. We don't know if this is true, but it will only take me 30 seconds to check. So x is negative 2, y is negative 4. Negative 2, negative 4, negative 2, negative 4. I'm checking. 2 times negative 2, negative 4. 3 times negative 4, negative 12. Negative 4 minus 12, negative 16. Correct. 5 times negative 2, negative 10. But negative 10 times negative 4 is positive 40. Positive 40 minus 10 is indeed 30. And only now I'll say yes. I would like us to choose a word problem that converts into a system, or if you would like to work on another system, or we move on.
Can we do 46?
Yes, 46. 46. Let me look. Where is it? 46. Oh, yes, perfect. Excellent. It's a word problem. 5, 5, 5. Good, let's read it. The sum of 3 times a first number, the sum of 3 times the first number, and twice a second number is 8.